Apache Kafka is immensely popular and used in production by some of the world's biggest companies. But what is Kafka? Rather than see the world through the lens of objects, Kafka sees the world through the lens of events. These are things that happen rather than just exist. When an event occurs, it's placed onto a log. Kafka calls these logs topics. Topics are easy to scale in Kafka, which is one of the reasons it's so popular. In practice, Kafka is often used for different components of a system to communicate. A producer will put information onto a Kafka topic, and a consumer will read information from a Kafka topic. So let's get going with Spring Boot and Kafka. So we have the Spring initializer here, which allows us to download a skeleton project for us to start work on, getting us up and running quickly. So we can see here we've got a couple of options. We've went through these in past tutorials, but we'll just go through them quickly again now. So the first thing that we're choosing is the type of project that we want. Now this is basically specifying the build tool that we want to use, either Gradle or Maven. But if we're choosing Gradle, then we need to specify the language if we're using a language other than Java. We're going to be using Maven today, and we're going to be using Maven with Java. So we're going to select Maven as the type of project, and the language stays over here at Java. The version of Spring Boot that we want is 3.02, which is the general release version at the moment. And now we're going to fill in some project metadata. So we're going to call this the group com dev tiro, and the artifact is going to be Kafka tutorial. And we'll just say a Kafka tutorial using Spring Boot. And we can see here we've already got a package name, and that looks like a decent enough package name to me. And now we select our packaging, either a jar or a war. We want a jar, so we could select a war, which is the traditional option. And what that allows you to do is deploy this application to a running application container, but we want it to run inside of its with an embedded application container. So what this means is by selecting jar here, we essentially can just execute the jar file rather than having to then deal with some extra bits and pieces. We're going jar because it's simple for the time being. And the version of Java that we want, we're going to go with version 17. And now we can start adding some dependencies. So Spring is obviously fantastic because it's so modular. What are we going to need today? We're going to need Lombok. We don't need Lombok. Lombok allows you to reduce the boilerplate code in your project by using annotations, those @ signs that you can put on top of classes and methods and things. We want Lombok to speed us along, and we are going to use Spring Kafka. So there's an option here between normal Spring for Apache Kafka or Spring for Apache Kafka Streams. We're not going to go into Streams today. We're just going to go through the normal old school Apache Kafka to get us up and running. And that's all we're going to choose in the way of dependencies. So if we click on Generate, downloads as a zip file. And I'm going to now open this up in Visual Code Studio. And here we are in Visual Code Studio. So let's just take a little look at the project. So we'll just zoom in over here. So we've got a source main Java. We just have a single tutorial application here. So this is the bare bones to get us up and running with a Spring Boot application. You can see the Spring Boot application annotation on top, which designates it as such. We take a look down here. We have a test, which just tests that the Spring context loads. Nothing too special there, but a great start. And then in resources, we have application.properties, which is where we will put any configuration for this project. So a completely blank project, more or less. So where do we go from here? Well, before we even jump into any code, we want to have a running instance of Kafka. And we can do that using Docker Compose. So Docker allows us to run Docker containers. So in this case, in the case of Kafka, we'll have a Kafka container. And we'll also have a Apache Zookeeper container, which is a dependency of Kafka. It requires it to run. Now, luckily, over here, Confluent, which are the company behind Kafka, have some instruction on how to do that right here. And I'm going to take the liberty of taking this Docker Compose file right here. I'll leave a link to this in the description below so you can do the same. I'm going to take that, go over to Visual Code Studio, and then I'm going to create a file in the root of the project. And I'm going to call this one docker compose.yaml. I'm going to dump in what I've copied here. And we'll just go through this very quickly. So the Docker Compose file allows you to run an environment of multiple Docker containers, which is what you need in the case of Kafka, because you need both the Zookeeper one and the Kafka one as well. And you can see here, you can put in environment variables as passing the configuration to the containers. So we can see here, we've got Zookeeper running, and there's a Zookeeper Docker image, there's a version, container name, and then some configuration, which just seems to be port tick time. And then we've got the broker, so the Kafka broker. So that's the thing that our application is going to connect to. And we've got here the Docker image version. The container name is broker. The ports are being exposed, which is 9092, which is the port we're going to connect on. And you see it depends on Zookeeper. So Zookeeper is going to be started up before the broker. And we've got some environment variable configuration here. We won't go into this in too much detail, but this is kind of a very vanilla starting configuration. Kafka is highly configurable. If you're interested in all of that side of things, it's well outside of the scope of this video. The documentation is very good for all of the different configurations available. So let's start up these Docker containers. So you will need Docker installed. Now I've got Docker installed on the Mac here, so I've got Docker for Mac. Now there's a couple of ways of starting this up. I'm going to do it the command line way. So I'm going to bring up a new terminal. Let's zoom into this terminal down here. Now we are in the root of the project. And if I list out the files, we can see here that we've got, oh, wow, okay. So I've put Docker Compose in the wrong place. Where did I put that? It should be in the root. And it's not. Let's move that to the root. Silly goose. There's our Docker Compose file. You'll want that in the directory that you're going to run this next command in. And the next command is Docker Compose up. Now, you can pass in Docker Compose up -d, which will run it in daemon mode, which will run it in the background, and then free up your terminal to use. But for transparency and for the sake of this tutorial, we're just going to run Docker Compose up, and you'll see printed out all of the logs from the running containers. So here we go. So you can see Zookeeper started up, the broker started up, launching Kafka, and everything looks like it's running fine. There we go. All good. So there's our Kafka and our Zookeeper up and running. If you found this useful so far and you want to see more videos just like it, be sure to subscribe. Now, if we were to go and open up a new terminal, for example, go all the way back here and then go Docker PS, we can see that we've got the Kafka container running and the Zookeeper container running. It's been up 27 seconds and our ports are exposed. There's the broker name and there's the Zookeeper name. So we've got Kafka running. We'll need to now create a topic for us because we need to connect to a certain topic with our application. On the Confluent page, there is some information on how to do this. If we scroll down, we can see here, creating a topic is fairly straightforward. So we're going to, in fact, take this. We're going to go back over and we're going to zoom in, paste that down here. Now, if we just go through this quickly, we are essentially Docker exec means we're executing this inside of the Docker container broker. So as if you're running the command line inside the Docker container. You can see here that we are connecting to the broker on 9092 and we're creating a topic called Quick Start. For the sake of this tutorial, we're going to create a topic called customer.visit, which is going to model or kind of sort of model a customer visiting our website or our system. So if we create a topic called customer visit, there we go. We've created a topic called customer visit. So we can now connect to this topic. So let's write something to do just that. So this isn't strictly needed, but it's a good opportunity to show you configuration properties inside of Spring Boot. So configuration properties allow you to load in custom configuration into your project in a really nice way. And we're going to use this to pass in the name of the topic that we want to connect to. So if we go over to our tree here, we're going to create a new folder and we're going to call this one config. Inside of config, I'm going to create a new class and I'm going to call this one Kafka config props.java. There we go. It's creating me a class, a little bit of boilerplate. Now we're going to use lombok at data, and this is going to generate us our getters and setters, our hash code equals, all of the stuff that you need for a general class. And we're going to go all R's constructor to have a constructor generated with all of our arguments, no R's constructor, a constructor without any arguments, and then a builder. I tend to use these on any sort of general data structure classes that I create. And we want to have a single instance variable, and we're going to have this as type string, and we're going to call this topic. So this is just a plain old Java object at the moment, and it has a single instance variable, which is topic. The way that we turn this into a configuration property is with this here, configuration properties. Okay, and we can see we've got a couple of different options for arguments, but we're going to say prefix, and we're going to say the prefix is devtiro.kafka. And this will be the prefix that we use for our properties inside of our configuration file. So configuration properties allows us to have this prefix, devtiro.kafka, and then it looks for the names of the variables in our properties file. So this will look for devtero.kafka.topic when loading in configuration. I am going to put at configuration on top of this, which tells Spring when it's loading configuration to load from this file also. And now we will go over to our resources, into our application properties, and we're going to create a line devtero.kafka.topic, and our topic was called customer.visit. So now this is available for us when we are inside of the application. What we're going to do initially is we're going to create a Kafka producer. So we're going to put some messages onto this topic. And to prove that the messages have been received by the topic, we're going to have a command line consumer run from that topic. So it just so happens, if we flip back over to the Confluent documentation here, this shows you how to write messages to the topic from the command line, but we just want to read messages for the time being. So here it is. Very similar to what we ran before. So inside of the broker, we're going to call the Kafka console consumer, connecting to the broker. We will need to change the name of the topic, and then it's going to read messages from the topic from the beginning. Let's take this, and then let's change the topic from quick start to be customer.visit. And then this should do not a lot because we haven't sent any messages to this topic yet, but this is where they will appear. So we're going to leave that there. Let's just zoom in. So they'll appear just here. It's connected, but then no messages have appeared just yet. So we need to send some messages. So how we're going to send messages, it's fairly straightforward inside of Spring, but we need to first decide on what type of messages we want to send. So you can send many different formats of messages on a Kafka topic. You can do a plain string, you can pass JSON, you can pass binary objects, which allows you to use technologies like Avro, for example, which will then serialize your messages into a nice, compact and efficient medium to then transport over the wire. However, we are going to just pass over JSON in this case, and we're going to model it by using a Java object, a POJO. So we're going to create this POJO, we're going to populate it with some information, convert it into JSON by using Jackson, which is again built into Spring or in the Spring ecosystem, and then we're going to pass that to the Kafka producer, and then it will go on to the topic and it will be read just down here. So before we can do that, we need to model our event, model our message. So we're going to create a folder up here, and I'm going to call this one domain, and I'm going to go into domain, and I'm going to create a new file, and I'm going to call this one customer visit event.java. There we go. It's giving us a very basic boilerplate, and we're going to do all of the things that we did before in Lombok: at data, at all R's constructor, at no R's constructor, and builder. Now, it's actually quite important that we do have this no R's constructor in this case, because this will be the mechanism that Jackson uses to populate our class when it's deserializing, which it won't necessarily be doing, but it's something that Jackson needs nonetheless. What sort of information do we want to pass in our event? Now, this is completely open to you. I'm going to use some examples here. I'm going to have a private string, and I'm going to call this one customer ID, and that's just going to be the ID of the customer, potentially as they visited our website or they've started to use our system. We might also want to have a timestamp. Now I'm going to use the local datetime that came along with Java 8, and I'm just going to call this visit time, I think, or maybe just date time. There we go. So this is a customer visit event. We can add to this as and when, but for the time being, a customer ID and then a date time I think will be good enough for us. So in order to convert this into JSON, we need to configure Jackson. So when we use any of the Spring Web stuff, Jackson comes along for the ride. However, because we've just gone pretty light and we've chosen just to use Spring Kafka and Lombok, Jackson isn't in this one, and we need to bring in Jackson. So I've already got over here, zoom out, the dependencies that we need. Let's grab these, and then I'll explain what these do. So going to drop these into the dependency nodes. I'm going to do this one above the test dependencies, just to keep things nice and organized. And let's format this file, shall we? So Jackson is, again, very modular. So we're bringing in Jackson data binds, which is usually everything you need, more or less. You use Jackson. That then brings all the other dependencies that you need along for the ride, Jackson core, etc. However, because we're using the local datetime, we need to use this particular module as well. And that allows us to convert our datetime object into the string that we want. So it allows us to deserialize and serialize the Java 8 datetime objects. In order to make Jackson available, you could just create it each time, but let's put this in our configuration and put it into the Spring context. Let's go over to config, and let's create a new file, and we're going to call this one JSON config.json. Java. This, of course, is configuration, and we're going to create a public object mapper. And object mapper is the Jackson object that we're going to be using to convert our Pojo into JSON. And we need to use the bean annotation to tell Spring that this is a bean and to put it into the context. So now we need to create our object mapper. In the basic way of doing this, we could just say new object mapper, and then we can return it like this. And that will return a new object mapper that we can then use throughout our application in the Spring context. However, we need to add the module to allow us to convert our date times. So we actually just need to go final object mapper, and then we need to do final, and then we need to do object mapper dot register module, and the name of the module, which I always forget, is Java time module. So that will allow us to convert our local date time into a string. However, it won't tell us how to format it. So let's tell it how to format it, and we can do that with object mapper dot it's set date format, and then we need to do the format that we want, which we can represent with a new simple date format. And then we can use the standard string for this, and we're going to use the ISO version, so it looks a little bit like that. That looks right to me. And that's telling us how to configure it. And of course, we just need to return our object mapper at the end. There we go. So that object mapper is now available to us in the Spring context. So we can actually get down to business now. So if we go over to the main here, obviously we're not building a whole application for this. So we're going to put a message on the topic right here in the Spring Boot application class here. And the way that we're going to do this is by creating a bean, and we're going to create a public application runner, and we'll call this one runner. And what is this going to need? Well, it's going to need the Kafka template, which is the abstraction that Spring uses in order to interact with Kafka. So we need the Kafka template. And now we need to pass in some generics. So we're going to tell it the type of the key that Kafka uses, or at least our type is configured to use. In this case, will be a string. And we need to tell it what the payload is going to be. So we're going to convert our JSON into a string to pass it in. So we'll put that there. And we'll call this one Kafka template. And I'm also going to specify that we need our Kafka config props. There we go. And let's make both of them final. Again, just good practice, make things final so they can't be reassigned, because why on earth would you want to? And I don't think we've imported bean, so let's import bean. Okay, and now we can get on with sending a message. So first things first, let's create our message, and we can do that by creating a customer visit event, and let's use our builder, and we're going to say the customer ID is going to be randomly generated, and we can do that using UUID, random UUID, and then toString, and that will create us a random UUID, a universally unique identifier. And now for the date time, and we can do that with local date time. We'll just set it to be now, which we can do like that, and that will create us a local date time, which is now. And then we call build, and that will return us a customer visit event. So we'll say final customer visit event equals, there we go. So we have now an event that we can send. Well, can we? Because it's not JSON yet. So let's turn it into JSON, and we can do that by getting hold of our object mapper. We don't have a constructor for this class. We're just going to do this in the quick and dirty way. So we're going to go auto wired, and then we're going to go private object mapper, which is available in our context because we've already created it and configured it. We now have our object mapper, and we can call this object mapper dot write value as string, passing in our event, and that will create us a final string, and we'll just call this one payload. However, it is going to throw an exception in this case, a JSON processing exception. We may want to handle this, or we can just throw it up. It's good practice to handle it, but as this is an example tutorial, we're just going to add it to the declaration, which is going to then throw it up. You can see it added there, throws JSON processing exception. So we now have our payload. We now need to send it. And we're going to use the Kafka template for this, but we just need to return a function because we're using the application runner here. And the easiest way to do that is by going args, return args into, and now we're going to call Kafka template.send, and now we can specify a number of things. We're going to specify the topic, and we're going to get the topic from our Kafka config props. So Kafka config props dot get topic, and now we can send our message, which in this case is going to be our payload. Go, semicolon here. Okay, wonderful. So we are creating our customer visit event, which is a Pojo. We're populating it with some information, which is a customer ID, a random UUID, which we're going to call toString on. And then we've got date time here, which is just the date and time right now. And then that's converted into JSON, into a string, JSON formatted string formatted JSON. It's put into a string, which is JSON, and then that's going to be sent over here. Now we're doing it in this format because the application runner requires us to return a function which converts arguments into something. And we are simply just sending our payload, sending the JSON formatted string to the topic as specified in our configuration. So when we start up this application, we should expect this to send the message. There's one way to test this, and I think I'll just do a split on the terminal. This is a kind of a cool feature. And now we should be able to see messages come here. Now, I don't expect this to work first time, but let's see. So we're going to use the Maven wrapper. So when you download from the Spring Initializer, you get a Maven wrapper for you, which allows you to run kind of a pinned version of Maven. You don't have to install Maven. So we're going to go Maven, and we're going to go Spring Boot, which is a plugin inside of the Maven configuration. And we're going to say run. Now let's see if this runs, or if there's anything that we've missed. Compiling, running, build success. Okay, so it looks like everything's worked, but there's only one way to find out. So let's go over to the consumer. Okay, we can see here that our consumer has received a message. We've got the customer ID here, which is our formatted UUID. And we have date time here, which is formatted in ISO format, although it doesn't look like it has that Z at the end for Zulu, something for us to fix. But there we go. It sent a message, put it onto the topic, and we can see here that our consumer has read the message off. So it looks to me that this is doing what we want it to. But that's just doing the producer part. We can also do the consumer part in Java in Spring Boot. And actually, it's a lot easier than doing the producing. So the way that we do this is simply with an annotation, which we can do inside of this same class. So what this is going to mean is every time we run this application, it is going to send a message, but then it's also going to try and read a message off that same topic. And we do that with this annotation, which is the Kafka listener annotation. Let's zoom in, and it takes a single parameter, which is the name of the topics or topic pattern. Because this is an annotation, we unfortunately just need to pass this in customer visit. Now let's create a method to go along with this. Public void, I believe, because it's not returning anything. And we're just going to call this one listens. And we're going to pass in a single argument, which is of type string. And we're going to call this ins. This is it listening to a message, and it's going to receive the message, which is going to be a string. And what do we want it to do with it? Well, actually, we're just going to call system.out.println on it. We just want to see what the message is. Actually, I think I may have been wrong there. I'm pretty sure you need to return from this. So in which case, we're going to also then return the message. Okay, so this is just running through. Using the Kafka listener annotation, we're able to specify a topic for it to listen to. When a message is put onto that topic, it reads it off, and it's represented as a string here and called in. All we're doing in this case is we're printing it out to the command line. So when we run the application, it will still put a message onto that topic, but it's also going to read off messages from that topic also. So before we can do this, though, we're going to need to pass in some additional configuration. As you can imagine, this is very simple, but it does rely on a little bit of configuration to be put in place. And we can put that into our application properties. So let's go over here. So there's our one from earlier, but we also need to specify a couple of other bits of information. The first one is the address of the brokers and how to connect to them. And the key for this one, which I could never quite remember, is spring.kafka.bootstrap, not Nootstrap, bootstrap servers. And then with the address for the servers, which we know in this case to be localhost 9092, because we're running that inside of Docker. And there's going to be a second one that's required as well, which is the group ID. So how we identify this consumer with the broker. And that one is spring.kafka.consumer. And then it's group, and I believe it's hyphen. Yes, it is group ID. And we're just going to call this, one, I don't know, let's call it events. It could be anything. Tutorial, it could be anything. In fact, events is as good as any, isn't it? Okay, so this is saying connect to the broker on this address. And by the way, the ID of our consumer is events. So if there were multiple consumer with the same ID, that tells Kafka how to deal with them. And if they have different IDs, then it tells Kafka how to deal with them. Let's give this a test, shall we? And then let's zoom in. So we're going to run it how we did before with Maven Spring Boot Run. Remember, this is going to put a message onto the topic, but also attempt to read it off if everything's gone correctly. So we can see that it has put a message on again. And if we were to dig through here, I'm sure we could probably see a message. But actually, I think there's a better way to test this. Let's use from earlier. let's turn off the consumer. Let's put a couple of new lines. There we go, we've done that. And now we're going to, one I made earlier, use this command. And what this is going to do, in the same way that we had a consumer running before, this is going to create a command line producer and then give us the opportunity to put a message onto the topic. And then let's attempt to run this. And it's using the topic customer.visit, which is the same one that we're listening to on the right-hand side. See, there's this little greater than symbol. This tells us that we're in an interactive terminal now, or we're interacting with the Kafka console producer. So what do we do? I'm just going to take a copy of this message, I think, and we're just going to paste it in, and we're going to send it. And we can see on the right-hand side here, it's been printed out because our consumer is now reading off of that topic. Now, because we are simply just printing whatever we tell it, we can pass in whatever message we like. Hello. And then hello will be written here. Now, in a normal application, you would likely have a degree of validation on this one, where you attempt to pass a message potentially into JSON or something else, perform some validation to make sure that no dodgy messages get passed into your application. But again, that's just something that you can build on. That's all extra. This is the basics, which is that you can now produce a message and put that onto a Kafka topic. And you can also read messages off a Kafka topic using Spring Boot. As per usual, I'll commit this, push this on up to GitHub, and I'll leave a link to it in the description below. And there we go. That's how you would use Apache Kafka with Spring Boot. Now, if you want to get a little bit deeper into Spring Boot as a framework, be sure to check out this video where we use Spring Web to build a REST API. I'll see you over there.